See this question. A half wave plate and a quarter wave plate are placed between polarizer P1 and analyzer P2. All of these are parallel to each other and perpendicular to direction of propagation. Z is the direction of propagation. Light is propagating in Z direction. So all of them are parallel to each other and perpendicular to direction of propagation of unpolarized incident light. The optic axis of half wave plate makes an angle 30 degree with the path axis of P1. The optic axis of half wave plate makes an angle of 30 degree with the path axis of P1, and that of quarter wave plate is parallel to the path axis of P1. Optic axis of half wave plate makes an angle of 30 degree with the path axis of P1, and that of quarter wave plate is parallel to the path axis of P1. Means this is half wave plate. This is half wave plate. This is quarter wave plate. So it says the optic axis of half wave plate makes an angle 30 degree with the path axis of P1. The optic axis of half wave plate makes an angle of 30 degree with the path axis of P1, and that of quarter wave plate is parallel to the path axis of P1. Right. So we have to determine the state of polarization of light after passing through half wave plate and quarter wave plate, and what should be the orientation of the path axis of P2 with respect to P1 such that intensity of light is emerging from P2 is maximum. See, in all these cases, what you are finding is, in all these cases, whatever is happening along in xy plane. In z direction, it's only propagation. The field vectors will be lying in xy plane. The field vectors will all be lying in xy plane. So field vector, whatever change you have in the direction of field vector, or whatever be the change in direction, that's the same thing. So whatever change will happen in the field vector, they all will be in xy plane. In z direction, it's only the propagation which will take place. So let's try to see what happens in xy plane. Let me draw xy plane over here. Say this is xy plane, right? So P1, suppose the path axis of P1, let me assume path axis of P1 along say y direction. Let me assume path axis of P1 along y direction. Is there any information given to you? No, nothing is told about path of P1. So I can take path of P1 either along x or along y. I can take it either along x or along y, whichever you want, right? It just says these are parallel to each other, and optic axis of half wave plate is making an angle 30 with the path of P1. So let me assume we are free to choose path axis of P1. So let me assume path of P1 along y direction. So if suppose path axis of P1 is along y, suppose this is the path axis of P1. Say this is the path axis of P1, right? So light which will be coming out of P1 will have all its field vector along y. The light here the light will be plane polarized in this region. So the field will be lying along y direction. So E is E naught J, say I can write sin kz minus omega t, right? Sin kz minus omega t. Now this plane polarized light is falling on the half wave plate. This plane polarized light is falling on the half wave plate, whose principal section makes an angle 30 degree with the optic axis makes an angle of 30 degree with the path axis of P1. Whose principal section makes an angle of 30 degree with the path axis of P1, right? So say this is the path axis of, sorry, not path axis. So this is half wave plate. Suppose this is your half wave plate. This is the optic axis of half wave plate. So with the optic axis of half wave plate, the incident light, the field associated with the incident light makes an angle of 30 degree. So I told you the action of half wave plate on plane polarized light. Upon passing through the half wave plate, this plane polarized light will turn, and after coming from the half, first of all, when this will follow the half wave plate, this will break into ordinary and extraordinary. Then when they pass through the half wave plate, they will develop a phase difference of pi, and after developing a phase difference of pi, when they will superimpose after emerging from half wave plate, the light will again become plane polarized light with the field vector making an angle of pi minus theta with the principal section. Here theta is 30 degree, so now the field vector will make an angle of pi minus 30, that is 150 degree with the principal section of half wave plate. Means with this principal section of half wave plate, now the field vector will maybe make an angle of 30 degree. This will be making an angle of pi minus 30 degree with the principal section of half wave plate. So this can be something like this. This can be your field vector which will be emerging after the half wave plate, make an angle of pi minus 30, which is 150 degree, Alright, it will make an angle of 150 degree with the pass axis of half wave plate. It will make an angle of 150 degree with the principal section of half wave plate. It will make an angle of 150 degree with the principal section of half wave plate, and it will make an angle of 30 degree. Right, it is making an angle of 150 degree. Right. So after half wave plate, the light will remain plane polarized and will be making an angle of 150 degree with the principal section of half wave plate, where theta and pi minus theta has to be measured in the same sense. Right. Now, when this light will fall on the quarter wave plate, see the quarter wave plate, optic axis of quarter wave plate is along P1 only. Optic axis of quarter wave plate is along the pass axis of P1 only. Right. So optic axis of half quarter wave plate will be along Y. So with the optic axis, what is the angle which the field vector makes? It makes an angle of what this angle will be. This is 150, this will be 120, so this is 60 degree. Right. This will be 60 degree. I have all these portions. This is an angle of 60 degree. So a plane polarized light is falling on the quarter wave plate, making an angle 60 degree with the principal section. Make an angle of 60 degree with the principal section. So it will break into two plane polarized light. It will undergo a double refraction, giving you EY equals to E naught cos 60 sin kz minus omega t, and Ex equals to E naught sin 60 sin kz minus omega t. After passing through the half wave plate, quarter wave plate, one of them will develop a phase difference of pi by 2 and will become E naught sin 60 cos kz minus omega t. Right. So if I call it E2 sin kz minus omega t, and this is E1 cos kz minus omega t, then after passing through the half wave plate, your resultant wave will be elliptically polarized. It will be elliptically polarized. This will be E2 square equals to 1. So this will be elliptically polarized light, right, with more intensity, with your same major axis as, I write this, what will be same major axis? This one, E naught sin 60, E naught sin 60. Which one is higher, E1 or E2? E1 is E naught sin 60, E2 is E naught cos 60. So this one is higher. E1 is, right, E1 has E naught root 3 by 2 and E naught upon 2, right? So this will be elliptically polarized light. The nature of light will be, it will be elliptically polarized light. Now one of the questions says what should be the orientation of path axis of P2 with respect to path axis of P1 such that intensity of light emerging from P2 is maximum. See, you have the which one is higher, E1 is higher or E2 is? Intensity, you find that intensity of X vibration is higher, intensity of Y vibration is small. So if you put your path axis along X, you will be getting X vibration, right? So intensity of X vibration is high, you will get the intensity 3 by 4 E naught square, right? So you should put your path axis of P2 along X, that is perpendicular to the path axis of P1, then you will get the maximum intensity, right? So this is how you can solve this problem.